Objective number 5. Graph the log functions. Example number 6. Graph f of x equal log base 2 of x using point plotting. From the graph, state the domain and the range of the function. So graphing the log is a little difficult than we graph the other function we learned before. So first of all, I'm gonna write like this. Y equal step number 1. Y equal log base 2 of x. And we know that the log equation we can write as the exponential equation. The 2 is the base and the exponent is the y. Then 2 to the y equal to x. The reason why we doing this is because if you try to input for the function log, we don't know what x we're gonna input. So it's very hard to do so. We better convert it into the exponential equation. And it will be easier for us. Now we're gonna make the table. We're gonna make x and y. So from this table, you know that normally we make the x first, but you look at your equation, this is equivalent. 2 to the y equal to x. So x equal 2 to the y. It will be easier for us to input the y first. That means we will do the output first and then we find the input. We're gonna put the output is -2, -1, 0, 1, and 2. Then we have 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 square. Now the point is 1/4, -2. You know that when we make the point, we always make the x first, okay? So 1/2, -1, 1, 0, 2, 1, and 4, 2. Then we plot those points on the graph. First of all, 1/4 is the x. 1/4 like 0.25, -2. And then 1/2, -1. 1, 0, 2, 1, and 4, 2. And then we connect those points. After that, we can extend. You notice that you don't extend past the y-axis, okay? It will approach to the y, but no passing the y-axis. Now we answer the domain and the range for this graph. The domain is just from the x is very close to 0, but it's never 0. So it's from 0 to infinity, and the range is from -infinity to +infinity. You go back to objective number 4 and you record the definition. It said that the domain for the log function is from 0 to infinity and the range is from -infinity to +infinity. Over here, right? Okay, example number 7, we are doing the same job like example number 6. It just given us a different base. The base in problem 6 is 1/2, is 2, and the base in problem 7 is 1/2. The way we do will be same thing as before. and I hope you will remember. Do you remember, first of all, what do we do? In step 1, we will write y equal log base of 1/2 x. And then step number 2, go back to step number 2. Step number 2, we will rewrite as the exponential equation. So 2 to the y is not 2 to the y, but the 1/2 to the y equal x. And then step number 3, we make the table. Okay. X equal 1/2 to the y. And of course, it's easier to make y first. We're gonna make some positive and some negative for the y. And now we put it in to calculate for the x. One half to the power 0 is 1. 1/2 to the 1 is 1/2. 1/2 square is 1/4. 2 to the negative 1/2 to the negative 2 is 2 square. Because we reciprocal the base, the exponent change to positive. So we get 4 and 2 to the 1 for the second one. So we get the answer is 2. If you don't know this, go ahead use calculator. Okay. Then the point we make will be 4, -2, x, y. Okay, so 2, -1, 1, 0, 1/2, 1, and 1/4, 2. We will block those points on the xy coordinate. Now, first of all, we make 4, -2. 4 on the x and -2 on the y. 2, -1. 1, 0. 1/2, 1. 1/2 on the x and 1 on the y. And then 1/4 on the x and 2 on the y. Now we connect those points. We can extend them, and also you extend and its approach to the y-axis, but it's never touch. Now we answer the domain. The domain is from 0 to infinity because it's only on the right side, and the range is, you look at the y, you have some positive and some negative, so from -infinity to +infinity.